So this is a short video on triple product of vectors. Triple product of vectors is like this: A dot B cross C. Okay. Now what is the physical interpretation of this A dot B cross C? What is the physical interpretation of B cross C? Let's see. Physical interpretation of B cross C. So as you know, if there are two sides B and C, and represented by vectors, this is vector B and vector C, and the theta is angle between the vectors B and C. Sorry. So if you join this parallelogram, so B cross C represents the area vector of the parallelogram. Area vector of the parallelogram. So area vector means, you know, this B cross C is B into C sine theta, obviously. So area of the parallelogram is product of the side multiplied by the height. So that's C sine theta. And B cross C is in this direction, right? Dot means, you know, vector. The vector points this way, upwards, and perpendicular to the plane of the paper or plane of this parallelogram. So this is the direction of B cross C, or area vector of this parallelogram A. So A, area of the parallelogram, is B cross C. Now we are discussing here triple product. So A dot B cross C. Now let's bring in one more vector A, right, and say B and C. Vector B and C are in a plane, and A. Let's bring in vector A also here, right? And see, all the tails are tied together. We have joined all the tails of the vectors A, B and C. Now what is see this is the plane containing B and C, right? This one, this. Clear? This is the plane of B and C. Now what is the direction of B cross C? B cross C is obviously perpendicular to the plane. So this is the direction of B cross C. That's A, and this perpendicular to the plane is the direction of B cross C, or you can write it vector area A for this parallelogram. Now this theta is angle, say now this was theta, so this I will take as phi. So phi is the angle between this area vector A and vector small a, right? This angle is phi. Okay, so let's see, A dot B cross C is actually A dot this capital A, that is A sine phi multiplied by A. What is A sine phi actually? This A sine phi is nothing but the projection of the vector A on B cross C. So it's this length is equal to a, sorry, it's a cos phi, not sin phi. It's dot product, right? So it's a cos phi multiplied by a. Okay, so a cos phi is nothing but the component of vector a in the direction of b cross c. So that is a cos phi. Right, now we'll search about its physical interpretation. Now this is the vectors b and c. B and C. Let's make this parallelogram having sides B and C, and there you have A, and let's draw these parallel lines. Now this is the figure that we'll get, right? This is the figure that we'll get. So that's side B, that's side C, and area of the parallelogram is A, and this height and this angle is phi. This height is equal to A cosine of phi. Now you know this area of the base multiplied by the height A cos phi is equal to volume of the cuboid. It is volume of the cuboid of sides A, B and C, or rather vectors A, B and C. These are the vectors. This is B, vector B, vector C and vector A. Okay. So this is a physical interpretation of triple product. So if A, B, C are three vectors, then triple product signifies the volume of the cuboid with sides as A, B, C. So whichever way you approach, it is same. Say if you do B dot C cross A, you will get the same volume, right? Now, so one important point, note that it is also a way to check whether vectors are coplanar or not. See, this A dot B cross C triple product is also represented like this, A, B, C, right? Now for coplanar vectors, A, B, C, obviously you can check coplanarity of three vectors, right? A, B, C, they are triple product. A dot B cross C is equal to 0, or in any way you can write. You can also write B dot C cross A equal to 0, C dot A cross B equal to 0, doesn't matter. That means if all the sides are in the same plane, obviously the volume of the cuboid will be 0.